Now we're going to see a real voltage source or a practical voltage source. So you know that an ideal voltage source is a voltage source that produces a constant voltage, whatever be the resistance or whatever be the current is through the load. It always produces a constant voltage and its internal resistance is zero. But what about a real voltage source? So an ideal voltage source can exist only as a theoretical device. It's not practically possible. So now we are going to see what is a real voltage source is. Okay. So we are going to see a real voltage source. so consider, if you consider a practical voltage source, how can it be? It is just a voltage source. You have a plus, you have a minus, and say you have some 10 volts. This is a case, and you are going to have a current through this when you connect a resistance R. So what will be the current through the circuit? According to Ohm's law, if you consider the current as I, then I is the voltage V, that is 10 volts divided by the resistance R. This is the case. Now suppose the value of this resistance R, the resistance is going to be going to very small value. Suppose R is very small, then what happens? The value of I is going to increase because they are inversely proportional. So when R is decreases, I is going to increase. And suppose what happens when R is approaching 0 or R is tending to 0, what happens? I will tend to infinity, or the load current I approaches infinity, and which is practically not possible. Okay, so any practical source, it cannot produce infinite current. So why? What is the case here? So here the important thing is that all practical or real voltage source, they definitely will have some value of internal resistance. There will be some internal resistance anyway. It may be very small, but there will be this internal resistance. It is not like zero internal resistance as was in the case of a ideal voltage source, but a practical voltage source has a internal resistance R, and its value is not equal to 0 for a real voltage source. So if you consider a flashlight battery, it has an internal resistance. You denote the internal resistance as R. So if you consider a flashlight battery, so that is a source of voltage. So flashlight battery, it has, obviously, as I said, it has an internal resistance, a flashlight battery, and this flashlight battery has an internal resistance R, which is less than 1 ohm. So there is an R internal resistance and it is less than 1 ohms. Similarly, if you consider a car battery, you consider a car battery, that is again another source of energy that provides energy in the case of cars. So a car battery is also having some internal resistance R, and that internal resistance is less than 0.1 ohms. Okay, so an electronic voltage source may have internal resistance of less than 0.01 ohms. So that's the case with an electronic voltage source. So that is when you create electronic circuits or you create small electronic system, we will be using electronic voltage sources, and like any voltage source, they also have internal resistance. But in that case, the internal resistance R is it may be less than 0.01 volt. But one thing is clear: whether it's a car battery, whether it's a flashlight battery, or whether it's an electronic voltage source, all of this has some internal resistance, definitely is there. Okay, that means it cannot produce an infinite current, because this R can never be zero. When you decrease the resistance in the case of an ideal voltage, so this is the case with an ideal voltage source, that is, when R is approaches 0, the current will tend to infinity. This is an ideal case. But in the practical situation, the internal resistance R is not equal to 0, and therefore we cannot have infinite current. So what is the case when you have some internal resistance? The load current has to flow through the internal resistance of the voltage source. Okay, so in that case we will be having some internal resistance. Let this be the internal resistance small r. Then what happens? This current, load current, has to flow through the internal resistance of the voltage source. So due to that, what happens? Some voltage is dropped across the internal resistance, or you can say this as a source resistance. Okay, that means the load voltage is always less than the ideal voltage. So here you will have some ideal voltage, but in the case of a practical source, there is an internal resistance and some voltage is dropped across this internal resistance. So the voltage that is coming at this particular point will always be less than the ideal voltage. Okay, so that's the case.